My topic today has to do with introducing to Angular signal forms, a new era of reactivity on Angular forms. I would like to start with the reason why I chose this topic. Angular has been revolutionizing the framework. It started with Angular 17 and 18 when introduced the signals. The reason why they started introducing signals, it was that they wanted somehow to get rid of RxJS. RxJS is very complicated for newcomers and beginners to this framework. And in order to create a simple form, it meant that for newcomers, they needed to have very deep knowledge about, first of all, the framework, and second of all, the library, the RxJS. The reason why I chose this topic is, first of all, I saw a guy named Manfred, and he did a presentation about 2 weeks ago where he said that signal forms are coming and they are completely independent from observables. And I said, yeah, that's kind of amazing. And with that, I said, let me try to get my hand on and see what I can do. I took this example where you can see on the left, I tried to create a very, very simple form with first name, last name, email, age. And I also tried an async validator. And I said, let me see how fast I can build this app. I could do this in just a couple of hours without having a previous knowledge on signal forms. Here on the right side, I also presented on the demo. We can see that the code is quite readable and very simple. It's very straightforward and very, very, very readable. This brings us the question, what was the problem with the traditional forms? First of all, it was the RxJS complexity. As I said before, reactive forms heavily relied on RxJS. It meant that for everything, we had to have a very deep knowledge of this library. The second reason was boilerplate code. If you're familiar with reactive forms, we know that in order to have a very simple form, we had to know, for example, what are the form controls, form arrays, form builders, form groups, and etc. And the last reason is that the steep learning curve. So every newcomer who wanted to join this framework, it meant that it had to do a very steep learning curve in order just to get on board and to start with some simple forms and simple APIs. Then Angular said that we will come up to the task, and they tried to modernize the app starting from Angular 17 and moving forward. So how was the evolution of forms in Angular? Evolution of forms in Angular, if you all remember, if you started in the early 2016s, everything started with template-driven form. It was quite awesome, actually, to be honest, because in order to set it up, it was quite easy. Everything was in the HTML. If you needed the field to be required, you just put required in the template. If you needed a validation, you put it also in the template. For simple form, it worked perfectly. But what happened was that when the form started to get more complicated, also the template became way too heavy. You could have a lot of if conditions, you had the directives, you have the conditional rendering, which made the template to be very, very heavy. And testing and scaling it was very hard, because in order to test, it meant that you needed to render the view and then to start testing it, which meant testing was becoming more harder. When it comes to reactive forms, for reactive forms, it worked quite good. It was very scalable, very predictable, and very testable. But it has just one issue, the learning curve. As I said before, if you wanted to start with reactive forms, you needed to learn a lot of stuff, not only for Angular, but also for other libraries. And then Angular team presented the signal forms. With the signal forms, it was quite fast because it was using Signal, which was built inside the Angular. And it meant that we got rid of observables. But the issue is that this is still quite new. It is evolving, and it has a very limited community. So it means that we still have to wait until it gets more stable. The question becomes, what are signal forms? I just need to emphasize this. Signal forms are still yet an experimental API that has not been released yet. It is promised to be released in Angular 21, and we can test it. It's still in beta phase. And I think, as everything, it will pass the beta, and then it will become the mainstream where we can play with it, use them, and work and create components around them. Some of the key features, for example, for Angular forms are they have a single source of truth. They have reactive views, which means that when you bind to the template, it immediately changes the validation and the error handling. It uses signal as a primitive type. JavaScript promised that it will include in the future signal as a primitive type, not just as an not primitive, and it uses the model first approach. Also, it's good to say that it has a strong type safety, which is one of the key reasons why we use TypeScript, because it's based on the type safety promise. And also it means that it uses declarative validation, which means that when we create the rules are there, whether we need them or not, but whoever wants to implement them can implement them quite easy. And the most important, developer experience, which means that from Angular 17, they started to take care of us, the developers, finally. This is a basic example. For example, we have a data model on the left side with username, email, and age. In order to get into form, it needs to transform to a signal form, which each input becomes a signal, and that one can be passed to the form. Let's start with this example. What is the form and what are the components? As we can see on the left side, we have three main distinctive building blocks. The first one is the model, the interface, which contains of these three fields. After that, we have the schema, which is responsible for validation. And then we have the data, which should be a signal. And after data, we have the form, where we're creating the form. And we're passing the data as a signal and also passing the scheme. So we can think of the scheme as a blueprint of how the form will look and also how the validation will be implemented. And we can also think of the model as something that interacts between them. So the model can be the single source of truth where we communicate. Here, also in this example, there are some basic validations. We can see that required, min length, email, and minimum, for example, for type of numbers. What about built-in validators? Also, signal forms are coming with built-in validators, and some of them are quite well known. For example, we have the required, which just ensures that whenever we want to use the required field, we can pass it to the schema by using, for example, username or last name, and it will be required immediately. So the form will not be valid if that does not pass. We have the min length and max length, also built in, and I think they are self-explanatory. We also have the email, and min and max. They don't have to do with the character numbers, but they work for type number or type int, which means that we just need to pass a certain point in order to make this form valid. From this point, we have the built-in validators, but can we have also custom validators? And the answer is yes, we can. Because sometimes the built-in validators are not enough. Signal forms came with two types of validators. The first one is the validate, and the second one is error. We have these two types for a reason. The validate we can use, for example, when we want to validate something, but we want that the return response for that validation to be a bit more structured. When we want, for example, to have an array of objects. Maybe it's better if I show it in the example. This one, for example, we want to see if the email is passing. And we can see that it's starting with the validate, which is taking the value directly from the form. And then, for example, let's say we want a certain domain to belong to that user. It means that if the email doesn't end with that domain, we will return a message saying, for example, you can see that it's very well structured. It has a kind, it has a message. Otherwise, if this condition is not met, we will just return null or empty array, and it means that this validation passed. But beside that, we also have the error. We can see here in this second example, this returns a Boolean, a simple true or false. So if it fails, we can just return, for example, password must be at least 8 characters and containing certain characters. Otherwise, it will pass and the validation will succeed. I also wanted to talk about conditional validation. I think this is the hidden gem. Basically, it's to apply validation based on a condition. If we remember reactive forms, we had to know that, for example, in order to add a validation, we had to subscribe to an observable and to listen for value changes. Whenever the value changed, it meant that we either had to add an extra control or remove that control. And that became quite messy. It was hard to understand, and it meant that it could not be very certain because it was not type safe. And the custom validations came with two options. It was the basic conditional validation, and this one uses when. So for example, imagine having this schema, which we're passing an order, and we want that required field for a certain validation to be implemented only when something is matched. In our scenario, for example, we want that this validator to be triggered only if delivery method is shipping, which is quite nice. Or we can even say, for example, this field should be disabled when some if condition is met. It can be any type of condition. And the second type is predicate functions. Predicate functions come with two types. It's apply when value and apply when. It's quite similar. You don't have to worry about that. But we can say that the first one is only applied on field value, and the second one is applied when field state changes. So that's the only distinct part. So to see the example, we can see, for example, for payment schema, we want to apply a certain validation. For example, if method is equal to credit card, we want to make some field required, and we want to have a certain min length. So this is coming with conditional validation. And I think the conditional validation is the most important part when it comes to signal forms. What about nested forms? When we used to have an array with objects and with an extra array. Signal forms also handle that. They implemented a built-in feature called apply each. It means that if we had an array of objects, for example, imagine an address, that whenever you have to add another item in the list, it meant that we need to add extra validation each time. And apply each is the part that solves this one. Why apply each is good is because we have one single schema for each item. It means that it will stay consistent and we won't have a redundant code. I can demonstrate this by this piece of code. Imagine that we have this to-do item with a title and a completed of type Boolean, and this can be an array. Now imagine that you want to add another to-do and another to-do. In order for that to work, in the past, you had to add extra validation for each item. Now this is quite simple. Since we have the schema is imported to the main schema, it means that we can use apply each for each item that we add or we remove without having to care for the control. All we have to do is to pass the path of to-dos, and we can say whatever kind of validation we want to have. So this is quite simple and quite straightforward and easy to read. What about when we had to work with multiple field validators? Also, that one is covered. We had the tree validators. The tree validators has validate tree, which passes the schema. You can pass the whole schema or just a part of schema that is suitable for you, and it returns a context. That context is taking, for example, the value from one of your fields, and then it's returning that value, and you can do whatever you want with that. So imagine if you had, for example, a from and to, like saying you want to buy a ticket to travel to Pristina, and you're saying from Pristina to Pristina, that should be an error. And this is quite easy because we're getting the values directly from the form. It means that if from and to are equal, we are returning a very detailed error to the form. We're saying, for example, kind is round trip. We can define then in the template what we want to do with this error message. And we can say, for example, that this is the field that failed. We can pass as many parameters as we want. It's not an issue as long as we define it in our interface. I also wanted to mention that there are more type of validation. I didn't cover all of them. Another one is async validators, which is working on a synchronous call. That's also an example, but I don't have it with me. Now I would like to talk about another built-in function that's coming with signal forms, and that's submit. In the past, we used to make it like this. Imagine that we're having a save button. And whenever we press the save button, we had to make sure that first the form is valid. The form has been touched, and some fields are, for example, touched or dirty. Then we could say, hey, yeah, let's do this now. But this has been covered right now. We have now the submit, which takes the whole schema and returns you the form. This part of code will be triggered only if the form is valid. So if the form is not valid, this submit will not be triggered. It means that it will fall back to the return false, or if we want to do something else, display a message or something similar, it can fall after that. So this has been taken care from Angular signal forms. Now the question should be, should you migrate to signal forms? I would recommend you, because Angular 17 started with signals, and now they have come a mandatory part of Angular if you want to stay up to date, but not yet. For complex forms in the future, I would say yes, but for simple validation, we can still stick with template forms or reactive forms. But for now, it's still in the experimental phase. What did I gain from these signal forms? So I gained clarity, because everything is right there and then. You don't have to think a lot about it. We gained reusability because now we can split the schemas in multiple places and we can call them from different components without having to define the form in multiple places. We gained conditional logic, which is for me the best feature so far. And we also gained type safety and testability. I'm saying testability because as long as we keep the template untouched or with as little function as possible, it means that it's going to be easier to test. That's a keynote. What did I lose? Or I'm not sure if will count as a loss. We lost the CSS state classes. For example, we used to have the ng invalid when the reactive form used to fail. Now it's gone because it will be handled by the form, or even if we want it, we can add it by a custom class. We lost the template simplicity from time to time because in reactive forms, everything was handled in the TypeScript and nothing was handled in the template. But now it's like in between. Some stuff is handled in the template and most of the stuff is handled in TypeScript. And right now we don't have a stable API. As I mentioned before, this is still not released. It's going to be released hopefully in November. And the API is not stable, it's still in the experimental phase. That would be all. Thank you very much for listening. If you have any questions. Yeah. I also wanted to add that there are not a lot of resources. So if you jump right now into this topic, you will be the pioneer of it. But it means that most of the stuff that you need to investigate is going to be on your own time without too much links and too much information. But it's fun. Yeah.